Welcome to Performance Testing with Insights. My name is James Davis. I'm going to talk us through how we can set up application insights and also use it with Visual Studio Online performance testing. I always hate to ask these questions, but how many people here do performance testing and how many people are doing application insights? Just to make sure I'm not talking to a room that has no idea what I'm talking about. 1, 2, good. Everybody else know. All right, so ground up, all the way through. I work at Publix supermarkets. Most people here are from Florida, so you know what Publix is. We sell a lot of subs. It seems to be the biggest thing people like. Groceries are secondary to all the subs that we sell a day. I've been working there for 14 years. I've been on our performance team for 8 years now. I've been doing .NET for 10 years. I was doing it before I started on a performance team. And I've really been part of our, we do scripting, performance engineering, we do all that good stuff. We go and look at code, look at servers, and tell people what's going on with it, why it's doing it. We also do the low-level debugging. Part of the reason I have the debug things handle, we actually go in whenever there's a performance problem or even a production issue, we go and check all that out. We break it open to WinDebug, take a look at it, figure out what's going wrong, if there is anything wrong. Quick overview, I'm going to do a lot of demos. This is going to be demo heavy. So these first 5 bullet points will be done hopefully within 20 minutes, especially because my voice is very long and droning and it's the end of the day. People are probably going to get tired, so eat. There's a whole bunch of food over there. Talk about what I do a little bit at Publix for our methodology. I'll walk through Visual Studio Online, how we set that up, application insights, how that's set up, how they work a little bit under the covers, what you can expect to see from your load test and what you can expect to see from insights. And then also just some, obviously, high-level things you can do, what you find out when you do a load test. And just to level set, performance testing and load test, I'll use those two interchangeably. I'll say performance test and load test all the time. And it may mean one thing to one person, another thing to another person. So I actually went to Wikipedia and a few other places to look these up. Performance testing is that general term for everything. Load testing is a normal and peak load. Stress testing is when you try and kill it. You run it to the ground. And then we do soak testing a lot of Publix. We make things run for 5 days on end and at full load to see what happens. Does it shut down after 2 days of full load? Inside of your load test, you have a few other terminology pieces here. It's request, which is your single resource, HTML page, JavaScript, CSS, you name it. A page, which is all those items combined, and it measures those two individually. Then you have a transaction where you can group pages, requests, and everything else. And you can get we use that as a marker for like a user action. So if you were to select a drop down, it was to call a page or a request to get back more data, that may not look like anything. So whenever you go through your reporting, we can give it a great name like a transaction. Or you can give the transaction a good name like select drop down or submit form. That way we know what's actually happening whenever the user is doing something. Application Insights has a few things just to level set there. Telemetry, which is what they call their metric data. That's what's sent from your server, from your web page, out to the Microsoft Vortex servers. A dependency or a dependency request or dependency telemetry, whatever you want to call it, that's something inside of your main request that's sent out also, but it's linked up to that request. So say SQL or a web service, those will be dependency transactions behind that. Then the status monitor, that's what you install on your server to get all this dependency data and a few other pieces of telemetry out to Application Insights in the cloud. We'll talk about how you would get that installed on an application on a cloud service or how you get it installed on an Azure website. Now my methodology whenever I do testing is to try and find out what's really going to happen to the user, what's the real user story. How does that person come into the web page? How do they use the site? Do they come in? Do they go from the home page straight to the catalog? Do they go from the home page to order a sub? So we try and get those stories out, then we start making up a mixture of how those users are going to do that. We determine our peak load time, and then we shoot for that peak load time. As you can imagine, we have a time of year that's busier than other times of year. Thanksgiving, Christmas, Easter, those are really big times. So we plan for those really, really bad times. We don't really plan for the good Mondays or Tuesdays of the week. We do all of our load testing basically at that level. We also determine how many users we're going to have and virtual users we're going to use. A real user and a virtual user are completely different. A real user might sit on the site for 25 minutes, do some real actions and sit there and do nothing, but a virtual user costs you money when you're doing Visual Studio Online load testing. So you want that virtual user to have a great representation of a user action, but not sit around too long just wasting your time. And one thing we do also at Publix, if we can, we have a lot of back-end systems that feed into the main site and also to other systems as well. We exercise these other infrastructures the best we can. So we run batch jobs. We run other load tests that will exercise an ancillary system that will be loading data into our main system. So one load test could really be 10 load tests, depending on the size of the application. So Visual Studio Online, this is the in-the-cloud TFS. It's free for 5 users, and you get quite a bit of good stuff out of it without even having to pay any money. You get 5 users, you get an unlimited data store for your TFS solution, and you get 20,000 free virtual user minutes. This is $80 now. Their stepping is the first 40,000, I think, is at 0.4 of a cent, then 0.2, and then 1/10 thereafter. You're limited to 10 million user minutes a month. There's a hard limit of 10 million. I don't know how you could get that, unless you ran a 5-day long test with 1,000 users. That would get you there. You can call them or email them if you need more, but that's $20,000 you're already spending. I don't know if anybody's got that kind of capital for a load test. If you do, let me know. I want to talk to you guys about it. And then Application Insights, also free for now. It's still in preview, so some of the features kind of disappear on you. Matter of fact, I'll just go ahead and come clean. One of my last demos of the slide was dependent on being able to pull that data back into a load test result. Unfortunately, that feature was turned off sometime in mid-June. So since mid-June, when I was trying to get all this data lined up, it's gone. So I can't use it. It's still not active today, and they told me earlier this week they were going to have it active this week. They're running out of time, especially since their team is in Hyderabad. There are 3 components that you can use to get your insights out. Your status monitor, which is what we were talking about, where it's your local agent that gets you all of your back-end performance counters. It also is a CLR profiler, .NET profiler, so it's pulling back selectively instrumented method calls inside of .NET. There's a telemetry client, .NET API, which is what you can use to tell your code to send off specific bits of metrics or telemetry to the servers out in the cloud. There's also a client-facing or JavaScript telemetry client. That's how you can see page views when somebody switches between pages. You can measure how long it takes. If there's an AJAX request out to another server that's not even yours, you can monitor that from the client. So if you have a dependent request on, say, Twitter or Pinterest or something like that, you can find out how long it took to get that AJAX request back. So how it all works under the covers for load testing. I think everybody's used to a normal, if you went to Nick's presentation this morning, you saw how he used the browser and all those tools. This does not do that. This does not use a browser at all. This is behind the scenes. This is all raw HTTP. So it does have a few components like DNS and all those bits looking up, but it's not going to take the time and consideration of how long it takes to render the page. So once the bits are downloaded, that's it. It doesn't simulate that. It doesn't do anything like that. So if you're hoping to see real browser client time, you're not going to get to see that from a performance test. And that's not really what it's designed for either. You're designed to stress out the system at the best level possible. So you're going to be requesting all these bits of information, and your server's going to try and send back as much as possible. The playback is done from a number of places now. It used to be there was only one place in America. It was the Virginia data center they had. Now it's all the data centers that Azure has. So you can play from anywhere in the world to your site. So if you want to see what it looks like whenever you're coming from the East Coast, West Coast, obviously, if you want to come from Thailand, I think you can come from there, China as well. If you're not blocked by their firewalls, you can certainly be sent in. And all that data is sent and stored out there in their own TFS repository. Then when you download that, when you download the report, it's stored on a SQL Server instance on your side, if you have one. That's 2008 and higher. I don't think they go any lower than that. So how Application Insights works. This is deep. They do a lot more than just measure the begin and end of a page. First thing they do is they do the begin request event, and they see when you start a page, they give you an operation ID. That operation ID gets tracked through your threading all the way through, and every single telemetry event that they have thereafter gets that operation ID, which is how they link all those together. Even the CLR profiler picks that up from your thread storage. And whenever you're doing SQL whenever you're actually doing the SQL statements, that's done through SQL or events tracing. Some of it's done through the CLR profiler, but a lot of it's done through the actual event tracing. Your data is sent all the way back to Microsoft, so you have to have an opening in your firewall to do that. It's just JSON data sent over the web, pretty raw. It is secure, so you don't have to worry about that, but it is open data, so if you are sending sensitive information, don't. But if you have to send that information, like a person's name or some type of user ID, for whatever reason, just know that it can be collected like that. It's pretty easily readable. And there's no decodes or encodes that they give you. There's no base64, no MD5 hash. There's nothing you can use to obfuscate that. You have to do it on your own side and then undo that. And the results are saved in the cloud, and you can export them. They have a continuous export, which I'll talk about in the last demo that got replaced with the one that doesn't work anymore, where you can export that data out to Azure cloud location, to cloud storage, and then pull that down. And that's also JSON data. You can do whatever you want to do with that. Right now, premium's free, so you can get 30 days of premium, which gives you continuous export, gives you 50 million telemetry data points that you can collect in a month. So you get quite a bit of stuff right now to take a look at. So if you have a reason to use Insights in the next month or two, get on it, because you can really get a lot out of it right now for free. And then, of course, what can we find out? You can find out a lot of stuff whenever you do a load test. I think whenever you do client-side load testing, performance testing, you're going to find out that your clients vary from, obviously, machine to machine, from browser to browser, but your server has a very finite limit of requests it can send out, no matter what that browser is doing on the back end. So, also to touch on that as well, your load test will simulate real browser actions. So, say IE has 6 threads it downloads with, so is Chrome and everything like that. It will simulate that 6 threads, so you'll get the same amount of connections coming back, but you won't get, again, the load time and everything. But you can find out how many pages and requests per second you can handle. You can find out all of your system resources. And this is important because when you're in the cloud, there's no way to really get that data. I think you're using a cloud service, and you notice that you can see your performance counter is correct, and you have to go on there and you can get them from perfmon if you want to log into it. But do you export those now?
We're not exporting anything, just taking the first step.
Yep. And one of the things is if you're going to do a full performance test and you want to see that information, you have to really dig into it to find. You have to go through the whole management portal and start figuring out what their numbers mean. But with Application Insights, you can turn on specific performance counters and get that data as you're running your performance test. Of course, you can get SQL uses in your web service response times. You can get all that stuff too just from regular performance testing, but the Application Insights gives you that real deep look into it. You can test your network infrastructure. When we first put publics.com out there, we didn't have a big enough internet connection for everybody to use it. We didn't know that at first. We were thinking, oh, we're going to be fine. Well, we did the whole page load, and the first home page was like 7 megabytes. We trimmed that down. We got down to under 2, which is still large, especially for a small device. So they said, how many pages can we do in a second or in a minute? So we took our current production load, put that out in the cloud, ran it, and we found that we weren't going to be able to sustain that type of traffic without a CDN. So we ended up figuring out we needed a CDN. If we hadn't done that, day one launch of the site would have been disastrous. We would have lost probably 1,000 customers, 2,000 customers in the first hour because it wouldn't have scaled at all. But once we did that, we went that route. We went way offloaded with the CDN. We pulled everything back, all the features back that we wanted. And then about 2 weeks later, we were able to get, or actually it was 3 weeks later, we got a bigger internet connection coming in, and then we were able to support more of the features that we wanted. And of course, you can see what the effects of latency are. That bottom bullet's no longer valid, but it was valid whenever I ran my performance test. It was 65 milliseconds of latency from Virginia to Lakeland. So that's the closest we could get, and it still is the closest we can get. I think Miami we can get from there now. But we see that today, we see about 80 to 100 milliseconds of latency from all of our clients across the state because regular terrestrial and even your mobile, you're going to see quite a bit of latency. So we had to factor that in too when we started doing all of our calculations. Some of the benefits of testing in the cloud, you don't have to buy hardware. So if you're already strapped for cash, if you have a small budget and you can't spend over say $300 on this type of stuff, you can easily do that with Azure Insights, Azure and Insights. You don't have to set up any load generators, you don't have to do any configuration, there's no any startup time whatsoever, it's just click and go. You can use all your existing configurations. If you have a production or pre-production site that faces the internet, you just point your test to that URL and it's ready to go. And that's what I say about testing in prod. It's already configured. If you're already coming through the internet, if you're already coming from the outside, you should have all your rules in place, you should have all your systems set up, you don't have to do anything else. All right. So like I said, it's demo heavy, and I was pretty accurate when I said I'm going to burn through the first few pieces. And I'm going to talk about setting up Insights itself, how you can do that with a new application, how you can do it with an existing application. One other prerequisite, and I didn't go through any of these right away, is you have to have Visual Studio Ultimate or Enterprise now, the new SKU. So it is cost prohibitive to some people. Get your company to upgrade at least one license, and then you can do all this stuff. It is expensive, though. I don't have the number off the top of my head, but I want to say it's at least $4,000 for an Enterprise or Ultimate SKU. So just be aware of that. If you're a small shop, it may not be something you want to do right away. So I'm in 2013. Let's say 2003. And I'm going to go ahead and set up a new project and show you how easy it is to add application insights to a brand new project. So if you happen to have that, it's happened to me a couple times, you'll have to sign in to your MSDN account. That's how it's all linked together. I'm going to select a brand new ASP.NET MVC4 application. And over here, it's already checked. There's a checkbox. It doesn't get any easier than that. So if you or your development team wants to know how to set that up, instantly just go through or just to easily show them how you can do this. Now, if you have a couple of different applications or a couple of different MSDN subscriptions or even Azure accounts, you need to know that. I do have two Azure accounts, one for me and then one that Publix provides. If you have a personal MSDN account and you add this here, there's no way to export any of that data, so don't do that. If you have a company-wide MSDN or company-wide Azure setup, use that and get linked to it. You have to talk to your architects for that type of stuff. But if you do link it up to your Microsoft account, it will show up here, and it'll be that easy to add it in. Now, it asks you where you want to send your telemetry to. You can create a brand new Insights resource, and it'll name it your project name, whatever you give it. Or you can select one that's existing. I have a couple of them, App Insights demo, we did for Publix, and then a few other PowerShell demos that we were showing them how we can get some of our data out there. And of course, the Code on the Beach demo. If I select a brand new one and just call this COTB Live.
Do you basically set up one for every project?
Depends. If you're writing a brand new project, it might make sense to have it by itself. So the question was, do you set up one for each project? If you do that, you have a lot more instances to maintain and your data won't be pulled together. But if you do that, you also get quite a bit of telemetry data that you can use. So each application gets 5 million by default for free. So I'd recommend it if you're going through testing phases. And then when you get to a production level, if you need all of those systems to talk to one location, you can change that up.
Oh, so the free limits are based on the application insights resource, not on your Azure subscription?
Nope. So far that I've found, because each one has its own counter. All right. So if we've all created a website before, go through, click OK, select all the defaults. It'll build everything up, and it'll come up here and ask you or tell you that you're building a new Azure Insights location. You see it adding all the NuGets pieces. My Visual Studio is going to crash live. Good. No. Adding application insights to project, so it's going to get the NuGet package if I'm still connected. It'll download that, set up the application insights configuration file. I'll show you what that looks like. So this takes a second or two, and I'll keep talking through it. This is the easiest way by far to add a brand new application insights to your system. You see it right there, filling in everything, the AI agent, the intercept, dependency collector. I have found that they've been updating this thing quite regularly in the last 2 weeks as I've been prepping for this course. So if you go from week to week, you might not have the same exact version of application insights. I did find a small issue between 2 weeks ago and about a week ago. And my dependency injection, or not my dependency injection, but my dependency collector and all that didn't work. It just stopped working altogether. So I had to deprovision my Azure website, reinstall everything, and then update the NuGet package, and everything came back. That was not a great user experience. And I spent a couple days trying to figure out what was wrong with it, see if I could figure out if it was just a simple issue. And it was beyond what I could do with the, well, actually with the Azure website. So it was beyond what I could do with the console and everything. I couldn't log onto the system to uninstall anything. Had to do it all through command line, so I just killed it and restarted it. So when in doubt, reboot, right? So it already added this for me, Application Insights config, and one thing it does for you differently than you have to do by yourself if you add one after the fact, is it already populates this instrumentation key. So it spun up a brand new instance and gave this instrumentation key to me and already put it in there, so I don't have to do anything else. I don't even have to touch the web page. But if you happen to have a existing application, and this could be a problem because that's kind of the case, if you have one you're trying to figure out what's wrong with, you need to get insights onto the existing application. So let's show how we can do that, and I'll do that also in 2013. These are applicable to 2015 as well. So if you have 2015 already, what I'm showing you here will also translate right to that. New project. I'll deselect this. I'm pretty sure it'll come up again. And I'll leave that as. Should start a little bit faster. We'll see if I get the same object reference error. Nope. Now, once you have an existing application, no matter how old it is, as long as it opens up in 2013 or 2015, you'll have this selection right here. Add Application Insights Telemetry. It's almost the same exact procedure as before. Do you want to do a new one? Do you want to use a different account? What do you want to set up? So in here you can select which one you want to use. Obviously, pay-as-you-go or my Azure Ultimate. Use that account. And I can create a brand new Application Insights resource. This will do the same exact thing. So it's easy, no matter what. As long as you're in 2013 or 2015, easy. Hopefully everybody here is at least 2013. If you're not, raise your hand, I can show you how to do it without using 2013 or 2015. You? No, sorry. Okay. Yeah, luckily, like I said, 2015 is the same exact thing. So I also went back and did this in 2012, 2010, I think even 2008. As long as it supports NuGet or you can install the packages, it will go all the way back. I think 2008 is not as automated. You have to do a few extra steps. Namely, installing the references for the AI packages, adding a web config entry, and then adding a handler, adding Application Insights config, and then uploading that. So now we have this here, so I'm going to install this NuGet package. If I was to do this on a application or cloud service, you need to be able to add that to the cloud service. So that's the next piece of this. If you, now that you have Insights here and you turn this on and send it up, you're going to start getting some telemetry data back. You're going to get web requests. You're going to get a few timings here and there. You might get some some actual page timings, but you won't get you won't get as much as you need. So what we need to do is actually install the status monitor. And I can show you how we can set that up on an application or cloud service. I'm going to cheat because I already have mine open here. Inside of your cloud service configuration, oops, there it is, under the role and the CSDef. There we are. There is a task you have to add. So whenever it does the build and deployment, you add this task in, and I'll expand this over so you can see the whole thing. Now this task isn't something I just made up. There's a link online that tells you where to find this. If you just type in, if you search, and I have also the slide deck, I'll have this as well. You'll find where this Application Insights install agent batch is. This tells it to go download the Insight agents, install it, and then run it. There's a PowerShell that's involved here as well. So this piece also depends on you having a folder set up inside of your project. You see where it's called App Insights Agent. It can be called any directory name you like. But inside your actual project, you need a folder called App Insights Agent with this batch file and the PowerShell script. This will go out and download the proper version of the service monitor and also install it on your instance. So this is for a cloud service, but if you have a web application, it doesn't work this way. You can't just do that. You have to go into, and I'll show you that here, you have to actually go into the web application and add that. I think I have one set up. So if you go to portal.azure.com, you'll be brought up to the new Azure portal, which is very fancy looking. You can go find your web application. And under what I have is APM Performance, I can select Settings, Extensions. Give us a second. Click Add. Perfect. Inside of this extensions, what you would see is an Application Insights application or a extension to add. Once you click that, if it would ever show up, good. Under here, click OK. I must have missed another panel. That's very odd. Has anybody ever told you not to do live demos? This is why. Yeah, probably the Wi-Fi, more than likely.
If you were hosting on an application server running IIS, how would you
do this?
Yeah.
The question was, if you were hosting it yourself on premises, I'm taking it, you actually go and download that. You search for, I don't know the link off the top of my head, but Microsoft has this status monitor link out there, and you download it. It used to be on the Visual Studio Online page. There used to be a link that says, you know, what type of application are you running? Are you in the cloud? Are you offline? And you can select that from there. However, that's not there anymore. I don't know where it's at on this new setup, but you can find it online. So if you're at Application Insights instance, which is not going to happen for me today, unfortunately, you would then select the legal terms, you hit OK, and it would add that to your application, your web app. Then you could get all of your dependency data. You won't get certain things from a web app, so if you are running those and you're expecting to see like performance counters and a few other event-based things, you don't get that. Main reason is you don't have permissions. Your user account's locked down on the web application, so you can't see it. So now we can add application insights to any application we have out there. We can start refining the telemetry. So the telemetry is the data they send back. And inside of your application insights configuration, by default, it turns on quite a few things. Your dependency collector, which is everything for your SQL, your back-end web services, this is what will tag those to be captured by your status monitor. Your perf counter collector, which gives you an option to add any performance counter you want. It does have a couple of different, if you're used to performance counters, so most of you are, I'm sure, there's a little bit of a different syntax. You don't do splat or star, the name of the process. You can put in these wildcards and it will give you the name of the process you want. And then quite a few more are built in here. These are all extensions, and they will hook at any point in time in somebody's code. And this is how they get most of the dependency data. You don't have to, you can actually write your own extensions, use their API and add it in here, calling through their initializers and everything like that. One thing I can tell you could do if you wanted to, and this is what we started to do, if you get like Castle Windsor or some other DI framework, some other proxy generator, you can wrap just about any call you want, and you can track that as a dependency. It'll add a little bit of overhead, of course, but you can capture that, measure it, and then report that back to the web server, or back to the Application Insights. There may be something like a long-running process or a batch that's not standard. It could be using TCP/IP or something that's just not normal, and you can track that that way. That way you wouldn't have to go through every single bit of your code to do that. Otherwise, you have to go and add and I'll show you how to do that, add a stopwatch, and that stopwatch you then take that distance and then you add it to the dependency telemetry, and that can get tedious if you have 10,000 lines of code to go through. and plus it muddies up your code. But now that we have these pieces turned on, let's see what we can, how we can track a dependency. That's not common. In my home controller, I created a very, very fake dependency, which is a random thread sleep from 500 milliseconds to 3,000 milliseconds to emulate some type of traffic out there. What I created was a stopwatch closer to the top of this. Too far. System.diagnostics.stopwatch. Take that, I restart it right before I make the call. That way, if I used it previously, it will start back at 0. Make my call, which is my thread sleep call. Stop it as soon as it's done, and then use a telemetry client, which I have defined in each request, but you can define it in the whole controller if you needed to. That way, you can use the same one over and over again. And so if there's some type of context you need to keep, it will keep that for your entire life of the controller. So if, as it comes to life, and if you call other actions, it will make sure that they are all attached together. Then you call telemetry client track dependency. I named this external processor. I gave it generic thing of processed item, whatever number it was inside of my loop. I gave it the date time it started, which was defined right before I clicked restart, and the elapsed time. This last field tells you if it was asynchronous or not. So if you were making an async call and you did a wait, you could tell if it was async. That way they would know, you would know whenever your code comes back that it was sent out that way. And it's just a flag that gets tracked. It doesn't do anything very different. You can also add this to your client pages. Inside of my main view for this MVC application, I went to the main shared layout, and I added this tag. Now this tag is actually given to you by Application Insights instance. Whenever you go to your AI inside of the portal, the new Azure portal, there is a link for JavaScript clients. It'll give you this entire tag and everything you need. This is just to track every single page view. This, if you did go to the web performance talk this morning, this gives you a lot of the data that Nick talked about, and it shows it in a graph over time. So it will not be every single one of those load events, but it will tell you how long the browser took to download, how long it took for you to get your resources, time to first byte. It gives you that type of information. So now we have added a few extra bits to our new code. From here, we had to create a performance test. Should have enough time to burn through that. So to create the performance test, this is going to be probably new to a lot of people, aside from you two. So I'll try and go slow because it's a different topic. It's not like code. If everybody here is used to code, that's easy, but this is just a little bit different way of thinking. And it's easy. It's just a point and click record. You don't have to know a whole lot about it to make it work, but you have to know a lot more about your application to make it work well. That's what I try and tell people at work. If they're curious about making their own, we always tell them to really know their application, how the web works before you start doing this, because you can really just take this out of control. So to do that, if you want to add a performance test to your solution, you can add a brand new project under Visual C# or VB if you're that person, that one. You select the Web Performance and Load Test project. By default, it brings up where you want to connect this to. And if you want to do Visual Online testing, you have to connect to a Team Foundation version control. I'll click OK. It'll ask me which one do you want from this list if my machine doesn't crash, which it will. Once that comes up, I have about 5 or 6 different repositories for different applications out there. All my screenshots are saved somewhere else too. I have a whole bunch of those, so I can just walk through the whole piece. So I wouldn't have to go through this whole pain of doing it, but it's fun to do it live. I always like to test myself out. If you wonder why it started up so fast, I have a solid state drive. Without that, we never would have finished this. We now have to assume that I was able to add this to a cloud piece. And under my perf test, a brand new web test would be added in for me. So if you want to add a brand new web performance test, which is how you're going to do your real testing out in the world, right-click on your project or however you feel comfortable, and you go to add a web performance test. This will bring up a brand new browser. This is as simple as just browsing to your website. And that's it. Very simple. From here, I could say my user goes to catalog. Click on the link. It'll do its thing, download it, and send it out. Once I'm done, I can click stop. I'll get an invalid argument error, and everything will be great. If you do record this from your home machine or a machine that allows Bing, every time you type something into your browser bar, that's what you're going to get, your address bar. So I always just select these and delete them. Now notice I talked about we can add in a client for your JavaScript. That's what's being sent. And if I take a look at it, nothing there. See what's being sent by this one. There it is. So, unlike I told you before, this is clear text, not secure. So this is all the data being sent back from the browser, actually from the browser itself, not from my back-end machine, but from the client. So you see it's just a big JSON object. Grabs everything you need, all the data. So if you want to send this in while you're doing your performance test, you certainly can, but it will skew your results on application insights. So I recommend deleting it. I just wanted to show you what that looks like. So this is my simple web test. So I go to the home page. I might hang out here for a total of 1 second. I can adjust my think time, which is how long it is between each request that I'm going to do something. I can give it a realistic think time of something, say, 12 seconds. Sit there, scan the page, look for the data, read the news, look at the images. 12 seconds later, I decide I'm going to look at the catalog. That's saved. And then run my test, get another invalid argument. I guess this is what's going to be wrong today. You can run your test and make sure that it actually works. Sorry, this is awful. So you can run your test and make sure it works. And once it does work, and once it works the way you want it to work, you can go through and add these to a simple load test. I am going to skip a few of the advanced topics. I know some of you guys are already thinking about it, which is like extraction rules or some other pieces. It's kind of deep for the topic. But if you want to know more about how to make a realistic load test, come talk to me. I'll tell you what I've done and tell you some good ideas. After I create all my load test, I can add these all in, or excuse me, all my web tests, I can add them into a load test. As I was saying before, I know my percentages of what I'm going to do. So if my user story is most of my people come to the home page, and a few people go to the catalog, and a few people go to this what's called API heavy, where it's calling into the back end, I can set those up and say that of my 200, 100, 1,000 users, this percentage of them when the tests are running are going to be doing these things. Now I have my load test. I can also, I'm not going to run it because I'm afraid it's going to kill my machine. It's going to go up in smoke. But what I can do from here is make sure this load test works locally, that my percentages are right, and match all that data up. Now, to run it in the cloud, there's a little bit of different thing you have to do. And if you've ever run a load test internally, you just set it, you point it to your collector, or you point to your controller, it starts generating the load, and it collects all that data for you. But if you want to run it in the cloud, you have to do a little bit of different things. Inside of your local test settings, there's a radio button. It's this way in 2013 as well. You can tell it to run your test using Visual Studio Online. Now again, you have to be connected to a TFS or a Visual Studio Online resource to do this. If you're not, this option won't even show up. It'll be grayed out. And cancel that. Now the last part of my demo I was going to show you, and I'll at least show you here whenever it does come back online so you can be ready for it if you want to use it. Normally you would add in your performance counters to these. you would select what machine you want, you add a performance counter set to it, and tell it to record all this data over time. Since it's out in the cloud, if you do have a cloud application, you can't get that data. But they did have a way for you to tie in your application insights data to your load test if you're doing it in the cloud. So if you run a test and you have application insights, it will pull that data back with your load test results. And you can use that to see what your test looked like at that time, and it will get just your test results. So it'll be a very specific range of data. And then will also be metrics. So if you want to see how long it took for all your dependencies, that data will be there. If you want to look at any of your performance counters, that data will be there. You can graph it over time. This is great.
So is that the part that doesn't work if you can't download?
No. Right now this part doesn't work because they broke it. As far as you're talking about the stuff that if you don't download, your .NET application will send telemetry data without the status monitor. It just won't send as much. When I'm talking about your performance counters, that's what you won't get. And if you don't have your, also you don't have that, you don't get SQL data. So you wouldn't see your SQL calls in the back end.
But isn't it with the free application insights, you can't download data from application insights?
That's correct. The question was if you have the free version, you can't download. That's right for now. But again, the premium version is free for 30 days or for however long until they decide to turn it online for real. And then you can continue to export. I can show you what some of these panels look like. So the hope was to show you what it looks like when you add application insights. I'll click this, it'll probably crash my machine, but it's going to try and find it here at my VSO account, and it's not going to be there, unfortunately. Unable to connect? I doubt it. That's the error that I was getting at home with a real connection. So you can't find the AI data. It should come back online. Again, I don't know when. I'm not at Microsoft, but they said it's supposed to be this week. Let's look for some time in maybe late September 2016, and it'll be online. That's my guess. But it's cool. I did do it before, long before this. I was able to export data and graph that along over time with my load test to see how that data rose. But when you do run a load test, I can actually show you what one looks like. So if you are running a load test or have one out there, and let me make sure I am online, because that's probably the case. Yep. That would be a bad one. So load test manager, I can go find the load test that I'm running. This one I ran a little bit before we got into class, and I ran the whole thing for an hour, 200 users, and there are my load test results. Not a lot here that we can use. Unfortunately, there's just response time, throughput, user count, but there's no CPU data, there's no SQL data. I don't know how long things took. I know how long the page ran for. I can look at specific pages. I can go get into that detail, but I can't tell you what that page was doing. But with application insights, I certainly can. So inside the application insights blade, you can select a range. Now, by default, I think it comes out 24 hours, always. You can click on time range, select which time range you want predefined, or give it a very specific time all the way back up to, I think, 7 days for free. So you can go back 7 days and free no matter how many data points you have, or you can go back up to 14, 15 months in premium. So you can see there's quite a big block of blue over here while I was running my test. If I click on servers, this will actually show me what my server was doing in the cloud. I can see all the standard ones that I've only collected, available memory, my I/O for how much my disk was doing. I see my process CPU, which at the height of my test looked like I hit a whopping 18%. Even with 200 users, I was getting only 18% usage. Below that, you can see your request rate, where I was doing about 10 requests a second. So all that data has been captured and sent up for me automatically. If I want to see what was happening with my specific request at that time, I can select the server response time blade. This graph, this will show me all my response times and what my dependency duration was. So all the pieces inside of my web request that were making up their long response times. So there's a call out to a web service, there's a call out to SQL, there's a call out to my fake web service where I was randomly doing things. You can see that duration period here. Below that, you actually get the table data. So obviously the worst performing one was get catalog index, and that's because it hits a very awfully written SQL database that I wrote, because I am not a SQL developer. It is terrible. It takes about 10 seconds to get this data back. The idea was to have enough time to really dig into that data and show what you can do with it. But we can take a look at each individual request. And I can select the last one that I saw. It was about 2.3 seconds. And inside of here, I can see what's coming down. Now, you'll see a little bit of a discrepancy. You're seeing 2.3 seconds response time, but all of my SQL statements are about 3 milliseconds of execution time. Or 3, yeah. The reason being there is it's asynchronous, so it's capturing when the request went out and came back, but it's not capturing the actual render time of that, that block data that's coming back. It's not capturing the time it takes to render the full page. So even though I have 45 milliseconds of SQL time, I still have 2 seconds of unaccounted for time. And really that's because there's a large amount of data that has to paint. It's over like 1.5 MB, which is the primary reason this thing goes slow. But if I wanted to see if there was a SQL statement that is standing out and that is taking the most time, I can select that SQL statement and it tells me exactly what SQL was done. This is done by Entity Framework. So I didn't write this SQL, this is Entity Framework, so it's actually picking that up as well. So that's kind of a cool thing. This is very helpful performance testing and in the real world whenever you go live. And this is kind of the whole point. If you can do performance testing and get this data ahead of time, you can start doing your tuning, and then whenever you have problems, hopefully you don't, in production or you want to see what's happening in production, you can use that same flow to get back and find your problems or find the slow pages or find what could be doing it without having to go and start calling people middle of the night. You know, even if you get called at 4 in the morning if you're on support and you have AI up, you can go in there and say, okay, yeah, I see that we have a server down. I can see that we have a SQL statement going out of control. I can see what's going on inside my application. And you can wake up the right person instead of waking up 20 people. So that's most of the topic here. There's some other pieces you can see that we can walk through. But I'll just go on to the tips and let you guys get out of here, and I'll go hide my shame for having such a bunch of demos that just failed right away. First things first, have a plan. I didn't, and you saw what happened. You know what you're going to do for your projected load pattern. Keep doing it. You know, watch, rinse, repeat, and practice. Run the test from your local machine to ensure your rate before you go out to the cloud. Because as soon as you go out to the cloud, it's going to cost you money. As soon as you hit the start button, you're going to start wasting time and money. So if you have a 1,000 user load test, but you could pare it down to a smaller, say 200 user load test, and you just reduce your think times, maybe do that. Because you're going to be 0.2 of a cent every minute per user, so it'll add up quick. And when you do this, aside from having insights, get everybody on the line. You know, call your DBAs, call your server engineers, get them to look at other things as well. Because if you're looking at it by yourself and there's nobody available to troubleshoot a problem or to say, hey, yeah, we're seeing a CPU spike 1 core, but it's not you, I don't know what it is, maybe they can help you out with that. Or if the DBA is looking and says, oh yeah, we have a bad SQL plan, let me just go ahead and clear the cache. Did that fix it? Okay, cool, let's go. Record your performance counters along the test run. If you can't get application insights or if you can't get performance counter data together, set up your own monitors. So even though we're talking about insights in the lens of using it, if you can't, create your own. Add your own data, look at your own performance counters and try and catch that while you're doing your load test, and then augment all your data with that. By default, there's only one IP address for you coming from the outside. So if you have like a TAM or some other type of firewall that's going to stop based upon IP address, so that they think it's a DDoS attack from one machine, know that you can only get one. But if you email the group and tell them you want it turned on, they'll flip a switch for that specific TFS instance, and they'll allow you to run up to, I think, 200 and something IP addresses, which will kind of get around that issue. Add your firewall rules in IDS and DPS, because again, if you run this through and you have one IP address coming in, it's going to kill that IDS. It's going to scream and scream and scream and scream, and it might even expose a problem with that, which we found. One of our IDSs couldn't keep up with one single IP address running as many requests as it did, and it just started dropping requests, not because it was a bad rule, but because it couldn't keep up. We actually ran it to 100%. Once we went to across multiple IP addresses, that problem went away. I don't understand why. They said it was single-threaded on some reason. We asked them, they couldn't explain it, so we don't know. And now you can generate the traffic from anywhere. Used to be just in Virginia. Mentioned this earlier. If you have 2013, you go to 2015, update all your packages, remove it, and add it back in if you have a real big problem. Kill the entire application and start over if you can. You won't lose your name if you delete it. You can get your name right back. If you do add custom dependencies, you will duplicate data. If you add a dependency around a SQL statement to say that we're making a SQL call for user data, you're going to see two dependencies inside of your web request, and that may not be what you want to see. Performance counters don't work on your web app, so if you have a Azure web application, not a cloud service, you won't get your counters no matter what you do. You just won't get them. Or your traces, or certain types of Windows events. And I always like to tell people, use Glimpse if you can. Start at the beginning, use that first. This will help you if you're a developer. It'll help you if you're a performance tester to go take a look at the site and see what's really slowing you down just from a single page load. Get your deep inspection, you then follow hanging fruit right away. And that's it. I got time for any questions, about 9 minutes or so. If not, I will see you guys at the bar. Thanks.